So our next lecture is about fluid mechanics. So there are two branches under fluid mechanics, and these are fluid statics and fluid dynamics. Fluid statics deals with the study of fluids at rest in equilibrium situations. So these are based on Newton's first and third laws. So fluid dynamics is the study of fluids in motion. So first, we need to define what is density. So density is defined as mass per unit volume. So that is density, which is rho, will be equal to mass per unit volume. So rho is density in kilogram per cubic meter, mass is in kilograms, and volume is in cubic meters. So the SI unit of density is kilogram per cubic meter. So that is in CGS, okay, that is gram per cubic centimeter, and this is also widely used. So for this particular two objects, a wrench and a steel wrench and a steel nail, okay, so they differ in mass but they have the same density. Okay, so because the wrench and the nail are both made of steel and they have the same density in mass per unit volume. Okay, so the specific gravity of a material is the ratio of its density to the density of water at 4 degrees 1000 kilogram per cubic meter is pure number without units. So that is the ratio. Okay, so when we see specific gravity, that is the ratio of its density to the density of water. Okay, and it is unitless. Okay, pure number. So these are the densities of some common substances. You might need to memorize all of them. So for example, air is 1.20 kilogram per cubic meter, and same goes with water. Okay, that is 1000 kilogram per cubic meter. Seawater is 1.03 or 1030 kilogram per cubic meter. Steel, for example, given as 7800 kilogram per cubic meter. Okay, so you should memorize all of them probably. Okay, most commonly used in the problems are ice, okay, glycerin, iron or steel, gold, probably mercury. Most of them are used. Okay, so let us consider illustration 9.1. So on a part-time job, you are asked to bring a cylindrical iron rod of length 85.8 centimeters and diameter of 2.85 centimeter from a storage room to a machinist. Will you need a cart? Okay, so in order to answer this problem, you need to calculate the weight of the rod. So the question is, what will you need a cart to bring the cylindrical iron rod to the machinist? Okay, so solution is from our discussion earlier, our concept and principle. The density of a material that has a mass and a volume V is defined as density of the material will be equal to its mass per unit volume. So the given, okay, so the length of the rod is 85.8 centimeters, and converting this to meter, you need to multiply that by 1 meter per 100 centimeters. So the unit centimeter will be eliminated, and that is 85.8 multiplied by 1 divided by 100, so that gives you 0.858 meters. Okay, So that will be the length of the rod. Now the diameter of the rod is also given. Okay, so that is 2.85 centimeters. Converting that to meter, multiplying it by 1 meter all over 100 centimeters. Similar, centimeter will be eliminated, so that gives you 0.0285 meters. Okay, now the radius is given as, that is the half of the diameter, so diameter divided by 2, so the diameter is 0.0285 meters divided by 2, that gives you 0.0125 meters. So why did I solve for the radius? Okay, so we will be using this formula. Okay, so that is a volume. Okay, volume of the what? The cylindrical iron rod. Okay, so the volume for that cylindrical iron rod. Okay, so volume of a cylinder. So you need to memorize probably some of the volumes of geometric figures. Okay, so the density is the density given on the problem, so there is no density given. Okay, but then I had a density of what? Density of iron. Okay, so the density of iron is 7.8 times 10 to 3 kilograms per cubic meter. That is also the iron or steel from the some common densities of materials from the previous slide. Okay, so that is the density. Now the mass of the iron is found in terms of its density and volume. By the equation, mass will be equal to density multiplied by volume. So this is derived from this equation. Okay, so multiplying both sides by volume. Okay, so volume here will be eliminated, and that is mass will be equal to density multiplied by volume. Okay, now the volume of a cylinder is given by the formula pi RL, or pi radius squared multiplied by its length or height. Okay, so length is given, right? Radius is given. Okay, now substituting the formula of volume to this given equation, so that gives you mass will be equal to density multiplied by volume, but then volume is pi r squared multiplied by its length. Okay, giving you this equation. Now substituting or entering the values of the density, the radius, and the length, this gives you mass multiplied by density, pi, then radius squared multiplied by its length, and the answer will be 4.27 kilograms. So the question is, will you need a cart? So the mass of the iron is relatively small, so the person does not need a cart. So simply you can carry the cylindrical rod, and the length of the rod is less than 1 meter. So you can simply carry that to the machinist. So the answer on this question, will you need a cart, is no. So illustration problem 9.2. So a cube 5 centimeters on its side is made of metal alloy. After you drill a cylindrical hole 2 centimeters in diameter all the way through and perpendicular to one face, you find that the cube weighs 7.5 newtons. So what is the density of this metal, and what did the cube weigh before you drilled the hole in it? So for example, you have a cube, okay, that is 5 centimeters on each edges. Okay, and you drill the hole, okay, let's say on this face, and that is all the way through and perpendicular to the other face, so that is a through all face, okay. So literally, okay, so there's a hole. If you look at this, inside this hole you can see the other side, okay. Now after drilling the hole, this cube with the hole weighs 7.5 newtons, okay. So the concept and principle: the weight of an object of a mass m is the magnitude of the force acting on the object, so that is the weight will be equal to mass multiplied by acceleration due to gravity. And the density of the material that has a mass m and a volume v is defined as density is equivalent to mass all over volume. So given okay, so the length or the edges of the cube, so that is 5 centimeters, that is converting this to meter, you need to multiply that by 1 meter all over 100 centimeters, and the unit centimeters is eliminated. That gives you a unit of meters, so that is 0.05 meters. So the diameter of the hole, okay, 2 centimeter, converting that to meter, okay, similar procedure, so that gives you 0.02 meters. And the radius of the hole is diameter divided by 2, so that gives you 0.02 meters divided by 2, and that gives you 0.01 meter, okay. So weight of the cube with a drilled hole, so I used W prime, okay, denoting that this weight is the weight of the cube with the hole, which is 7.5 newtons. So the mass of the cube after the hole is drilled is found in terms of its weight by, so the mass of the cube with the hole is given weight divided by acceleration due to gravity, and that is derived from this equation. So dividing both sides by acceleration due to gravity, so this leaves you mass alone, okay, will be equal to weight divided by acceleration due to gravity, okay. Substituting the values, so the weight with hole is 7.5 newtons divided by acceleration due to gravity, and this is constant, so that is 9.81 meters per second squared. So the mass of the cube with the hole is 0.76 kilograms, okay. So the volume of the cube after the hole is drilled is equivalent to the volume of the cube without the hole minus the volume of the hole, okay. So volume of the cube with the hole is equivalent to volume of the cube with minus volume of the hole, okay. So volume of the cube has a formula of edge cube, okay, or sometimes if you going to search this formula, that gives you s cube sometimes, okay. So E denotes as the edge, okay, and that is pi r squared E. So what does this formula? Volume of the hole. So a hole is in the shape of the cylinder, so that is pi r squared multiplied by height or length, and that gives you this, substituting the values of the length of the cube, so 0.05 meters cube minus pi, radius is 0.01, okay, then squared multiplied by height or length, which is equivalent to the edge of the cube, which is 0.05 meters, and that gives you an answer of 1.09 times 10 to the negative 4 cubic meters. So this is the volume of the cube with hole, okay, and this is the mass of the cube with the hole. Now the density of the metal is found by, okay, so the density of the metal is given as, that is the mass all over volume from this equation, okay. So mass of the material, okay, or metal, which is with the hole, divided by the volume of the metal with the hole, okay. So substituting those values, that gives you the density of the material will be equal to 0.76 kilogram divided by its volume, which is 1.09 times 10 to the negative 4 cubic meter, and the density of the metal is 6.97 times 10 to the 3, okay, or 6,970 kilogram per cubic meter, and this is the answer for letter A. Now for letter B, okay, so what did the cube weigh before you drilled the hole in it? So the mass of the cube before the hole is drilled is found in terms by its weight, okay. So the mass, okay, without the hole, this is the mass of the cube without the hole, okay. So the density of the material multiplied by its volume. So we are solving for the weight, okay. So density of the material is 6.97 times 10 to the 3, right, or 6,730, okay. So the volume of the cube formula, okay, substituting the values, so that is 6.97 times 10 to the 3 kilogram per cubic meter multiplied by its volume of the cube without the hole, so that is 0.05 meters cube, and simplifying these values, so that gives you 0.87 kilograms. So this is the mass of the cube without the hole, okay. Now the weight of the cube is given this formula, okay. So that is the mass multiplied by acceleration due to gravity, so 0.87 kilograms multiplied by 9.81 meter per second squared, and that gives you the weight of the cube before you drilled the hole in it is 8.53 newtons. Now pressure in fluids. So we define pressure P at that point as the normal force per unit area. So that is pressure is equivalent to force all over cross-sectional area A. So force in Newton, okay, and area in square meters. So the unit, or the SI unit of pressure, is the Pascal, okay. So 1 Pascal, or simply that is 1 PA, Pascal, is equivalent to 1 Newton, which is force, per unit area in terms of square meters, okay. So atmospheric pressure is the pressure of the Earth's atmosphere. So this is the pressure at the bottom of the sea, the air in which we live, okay. So this is the atmospheric pressure is the above sea level, okay. So 1 atmospheric pressure is equivalent to 1.013 times 10 to the 5th power Pascal. So in unit bar, so that is 1.013 bar, or 1013 millibar, and that is in pound per unit per square inches is 14.8 70. So okay, uh, this is in terms of metric or SI units, and this is in terms of English unit. Okay, so pressure, depth, and Pascal's law. So if pressure 1 and pressure 2 are the pressures at elevations y1 and y2 respectively, and if density and acceleration due to gravity are constant, that gives you uh, pressure 2 minus pressure 1 will be equal to negative density, acceleration due to gravity, and the difference between the depth. Okay, so considering the figure, that is the absolute pressure P, okay, uh, will be equal to atmospheric pressure plus the gauge pressure. Okay, so this is the absolute pressure, okay, will be equal to atmospheric pressure, okay, at point 2, and this is the gauge pressure at a certain height or depth. Okay, so absolute pressure is we need to consider the atmospheric pressure at point 2 and the gauge pressure at a certain depth. Okay, so reminder, this is absolute pressure, atmospheric pressure, and gauge pressure. So Pascal's law, so that is pressure, okay, is equivalent to force all over uh, unit area, right? So pressure applied to an enclosed fluid is transmitted undiminished to every portion of fluid and the walls of the containing vessel. So that is uh, equal equivalent pressure. Okay, so that gives you this equation. So let us consider this definition. So absolute pressure is the total pressure, and gauge pressure is the excess pressure above the atmospheric pressure. Okay, now considering illustration 9.3. So black smokers are hot volcanic vents that emit smoke deep in the ocean floor. Okay, many of them teem with exotic creatures, and some biologists think that life on Earth may begin around such vents. The vents range in depth from about 1,500 meters to 3,200 meters below the surface. What is the gauge pressure? Okay, at a depth of 3,200 meter deep vent. So assuming that the density of water does not vary, express your answer in Pascal and atmospheres. Okay, so the question, we need to find out for the gauge pressure. Okay, so our concept and principle. So the pressure in a fluid with uniform density, okay, is given by absolute pressure will be equal to atmospheric pressure plus gauge pressure. Okay, so we need to determine the gauge pressure at a height or depth of 3,200 meters. Okay, so given, so ocean floor, okay, considering ocean floor, so the density of water is a seawater, and based on the table, the density of seawater is 1.03 or 1030 kilogram per cubic meter, and the height or the depth is 3,200 meters. So the gauge pressure at the depth of 3,200 meter vent is given using this formula, because we have considered uniform density. Okay, why we considered uniform density? Okay, so based on the problem, assume that the density of water doesn't vary, so uniform density. Okay, So this is the absolute pressure will be equal to the atmospheric pressure plus the gauge pressure. So uh, we are only dealing with gauge pressure, so therefore this is not considered. So therefore gauge pressure, atmospheric pressure is not considered, so that is 0. Okay, so density of seawater multiplied by acceleration due to gravity multiplied by depth. Okay, so density of seawater is 1.03 or 1030 kilograms per cubic meter multiplied by 9.81 meter per second squared, and the depth is 3200 meters, so that gives you 3.23 times 10 to the 7th Pascal. Okay, now this is the answer for uh, A, so in Pascal units. So this is 3.23 times 10 to the 7 Pascal. Now converting that value or that unit to atmospheres. Okay, so the gauge pressure in atmosphere is converting Pascal to atmosphere. So 1 atmosphere is equivalent to 1.013 times 10 to the 5 Pascal. Okay, so that will eliminate the Pascal unit, and that is in terms of atmosphere. So 3.23 times 10 to the 7 divided by 1.013 times 10 to the 5. Okay, that gives you 318.85 atmosphere. Illustration 9.4. Okay, a barrel contains a 0.120 meter layer of oil floating on water. So that is 0.25 meter deep. So the density of the oil is 600 kilogram per cubic meter. What is the gauge pressure at the oil water interface? Okay, so what is the gauge pressure at the bottom of the barrel? Now solution for this problem. Okay, we all know that if you mix oil and water, okay, they cannot be mixed together. Simply the oil will float on the water. Okay, so the concept and principle will be the pressure at position y1 can be determined in terms of the pressure P2 at position y2 by this equation, right? Okay, recall this figure. Okay, let's say now let's say this one. Okay, up to this point. Yeah, this one. This will be the oil in a container. Okay, and the remaining here will be water. Okay, uh, floating on water, which is let's say this has a depth of from this point. Okay, which is 0.0. This has a depth, okay, of 0.12 meters. 0.12 meters. 0.12 meters. Okay, and based on the given, this is 0.25. The first question is, what is the gauge pressure between the mm, oil and water oil water interface at this point? Oil water interface. Okay, and this can be simplified to this equation. This is the absolute pressure will be equal to the atmospheric pressure plus the gauge pressure. Okay, so given depth of oil is 0.12. Okay, here it is, 0.12. Depth of water 0.25. Okay, a density of oil, this is oil. Okay, the green colored highlighted, and the density of water from the table, that is 1000 kilogram per cubic meter. Okay, now the absolute pressure at the oil water interface is found by, okay, using this formula, okay, at that point. Now absolute pressure will be equal to that is the oil water interface, right? Okay, and that is the atmospheric pressure plus the gauge pressure of the oil level. Okay, this one. Now the pressure at the oil water level interface is the difference, okay, it's the difference between the absolute pressure and the atmospheric pressure. Okay, so the gauge pressure, okay, is equivalent to the oil water pressure level interface minus the atmospheric pressure, but then the oil water pressure is given this one. So substituting the oil water pressure to this equation, so that becomes atmospheric pressure plus gauge pressure of the oil, okay, minus atmospheric pressure, and that will give you this equation. Okay, so substituting the values, so the gauge pressure oil water level will be the density of the oil, which is 600 kilograms per cubic meter, okay, multiplied by acceleration due to gravity 9.81, and its depth 0.12, and that gives you 706.32 Pascal. This is the gauge pressure in the oil water interface at this point. Okay, now for letter B, what is the gauge pressure at the bottom of the tank? So the gauge pressure at the bottom of the barrel, is equal to the gauge pressure to the oil water interface plus the gauge pressure of the water. So that is the gauge pressure at the bottom will be the gauge pressure of oil water interface plus the water pressure gauge of the water, and that gives you 706.32 Pascal for oil water interface plus density of water, okay, acceleration due to gravity multiplied by the depth of the water, and that gives you a total of 3158.82 Pascal. So this is the gauge pressure at the bottom of the barrel. So water stands, so for illustration 9.5, water stands 12 meter deep in storage tank whose top is open to the atmosphere. What are the absolute and gauge pressures at the bottom of the tank? So bottom of the tank similar, okay, okay, let's say the tank is in cylindrical shape. Okay, so at this point this is the atmospheric pressure. Okay, atmospheric pressure, and the bottom of the tank, say that is the absolute pressure, okay, or pressure at the bottom of the tank. Now, so the pressure of fluid with uniform density, okay, is given as absolute pressure is equivalent to atmospheric pressure plus gauge pressure. Okay, So the given height or depth is 12 meters and the density of water is 1000 kilogram per cubic meter. So the absolute pressure at the depth of 12-meter depth is absolute pressure, okay, is equivalent to atmospheric pressure plus gauge pressure. So atmospheric pressure, okay, this is constant. So absolute gauge pressure, absolute pressure is equivalent to atmospheric is 1013 1.013 times 10 to the 5 Pascal, right, 1 atmosphere, plus density of water is 1000 kilogram per cubic meter multiplied by acceleration due to gravity 9.81 plus multiplied by 12 meters. So that gives you absolute pressure of 2.19 times 10 to the 5 Pascal. Okay, this is the absolute pressure. Now, the gauge pressure is simply this one, right? We said earlier that absolute pressure is equivalent to atmospheric pressure plus gauge pressure, right? So the gauge pressure is equivalent to absolute minus atmospheric, or simply rho gauge, okay? Or you can simplify that by using the values absolute pressure, okay, 2.19 times 10 to the 5 Pascal minus atmospheric pressure, okay, which is 1.013 times 10 to the 5 Pascal, which is equivalent to this value, 1.177 times 10 to the 5 Pascal. Or simply, you can also verify it by using this. Uh, Recall that this is the gauge pressure, which is also this value. And if you simplify this value, you can come up to this answer, gauge pressure.